The velocity of a particle moving along the x-axis is given by this velocity function. Which of the following gives the total distance traveled by the particle? Ooh, I know total distance between 0 and 3. Here we go. So this is our velocity function, total distance. So a quick explanation of total distance. I'm going to use this graph that I just made up here. I know it's not the graph of e to the x. We know what e to the x is. E to the x is an exponential function, but I'm just using this for an explanation. So as you see in this graph, we have a negative area and we have a positive area. If we were to just add up the negative area and the positive area, that would not give us a total distance because the negative numbers are going to cancel out with the positive numbers. That will end up giving us displacement. You remember displacement? We get that by just taking the integral from 0 to 3 of velocity. That would give us displacement, not total distance. So we have to take into consideration the negative area. And what we essentially want to do is we want to know when the area changes from negative to positive. Okay, so we have to know this point right here. And I chose 1 probably because that's all I see over here. I see a 0, 1, and a 3, or a 0 and a 3. So what we would do is we would take the area of the first part, the first interval from 0 to 1, and we know it's going to be negative. And so we throw a negative in front of it to make it positive. And then we add the other part, which we know is already positive. So then we're gravy. What we would get with that is the total distance. In fact, this is the same as taking the absolute value of velocity of the integral from 0 to 3. Whenever you get this with the absolute value bars, you have to find out where the x-intercept is for your velocity function. And we don't have to find it here. It's just kind of given to us, or it's assumed that we can see the graph of e to the x. But anyways, anywho, I guess, I found an answer right here. And I was like, yay. And then I looked at this answer up here and I was like, or the second answer, letter B, and I thought, oh shoot, it could be that one. Because what if my graph doesn't go down below the x-axis first, but instead goes above the x-axis first, and then goes below the x-axis? That would mean the second integral would have to be changed to positive, and so have the negative in front of it. So then I thought, shoot, I guess I do have to know what this guy looks like. And so I'm going to sketch a quick graph of the regular e to the x function. There he is. Now there's a couple shifts happening here. We have this guy, it says -1. That means we're going to move the function to the right 1. And then we also have this -1. That means down 1. And so something that really helps us is knowing the y-intercept with the e to the x function. We know that is 0, 1. And so that's what I'm going to shift around here. I'm going to first shift it to the right 1. And so now the point is at 1, 1 instead of 0, 1. Then I'm going to shift it down. When I shift it down, it looks like this. And I can see this little tiny area that's negative and this area right here that's positive. And so it's clear that our first guess was right. Okay, not the other one. Okay, the first interval is the one that needs to be changed to positive.